Okay, so let's take a look at this this thing here. And so all of these, graphs, all these monomials, if you have an even exponent, so when it says when n is even, okay, n is your exponent. Okay, so when your exponent is even and you have a monomial, okay, and if the leading coefficient is 1, a is 1, then you have a couple things you know about that. You know that that graph is going to be symmetric about the y-axis. So it's going to be, you have a line of reflection basically that is the y-axis, and all those points are equidistant from that axis. Okay, also you know if you have a monomial with 1 as your leading exponent or leading coefficient, and n is, and your exponent is even, you know you're going to pass through the point 0, 0. You're going to pass through the point negative 1, 1, and you're going to pass through the point 1, 1. Okay, if that's the case. All right. And we have two examples here. Okay, you have y equals x to the 4th, and you have y equals x to the 10th. All right. And what happens is that the smaller your number, smaller your exponent, the wider your graph is, okay? And then if your exponent gets bigger, then the faster that your graph goes up, okay? It's thinner, okay? And that's what this kind of means here. As n increases, the graph gets flatter, okay? As n increases, it gets narrower, so. That's that. So let's answer this question. Okay, it says for even monomial functions, y equals a times x to the n, where a is larger than 0, as x is greater than 0, okay, as x is larger than 0 increases, then f of x does what? What happens here? As f of x, as the x, so as your x value increases, okay, as x gets larger than 0, what happens to the function values? And when I say function values, those are y values. So what happens?
It increases.
It increases. F of x increases. Okay? As your x values decrease, as they get more and more negative, what happens to your graph here? It also increases. Those y values increase. Okay? So this is when a is positive, so a is greater than 0. Okay? Down here, this is when a is less than 0. So if your leading coefficient here is positive, that means your graph opens up. If your leading coefficient is negative, then your graph opens down. So as x increases, what happens to your y values? Do they increase or decrease? Decrease, yeah. Good Lord. Decrease. Okay, so as your x values get big, your y values get smaller. Okay, same thing, as x decreases, okay, as you look and see what happens to the left, what happens to the y values? They also decrease. Okay? And these are for even monomial functions. Okay? It's always the case. All right? Okay, so that leads us to this thing where we call end behavior. Okay? And basically, and we'll kind of talk about, okay, so end behavior of a function is what happens on the graph of a function as x goes to infinity or negative infinity. So end behavior just says, okay, as x gets really, really big, what happens to the y values? Are they going up or are they going down? Okay, are they getting bigger, are they getting smaller? And so what we know is, an even monomial function, okay, with a is greater than 0 goes to positive infinity on both ends. With a is less than 0 goes to negative infinity on both ends. Okay? And so then you could also say the same thing down here is if that leading coefficient a is positive, the graph opens up. As a is less than 0, the graph opens down. okay? And as if A gets bigger, then the graph narrows. If A it gets smaller, then the graph gets wide, okay? I'll kind of put this into terms that we understand at the end to kind of talk about that. In this one, all right, so we've been talking about even functions. Now let's talk about what it means to have an odd function. Okay, so an odd function is a function for which f of negative x is equal to negative f of x for all x. Makes sense, right? Yeah. I'm kidding, it doesn't. Okay, a monomial function with an odd exponent is an odd function. Okay, so you said something about what happens if you have x cubed. Okay, and what that means is that if you have a monomial with an odd exponent, then you can just call the function odd. All right, and so let me give you an example. Okay, and I'm going to kind of explain this idea because that's the definition of an odd function. Let's say I have the function, and let me zoom in here. I'm going to say, let's say I have f of x is equal to 4x cubed. Okay? What I want to do is I want to say, okay, if I take f of negative x, if I plug in negative x into that function, then I get 4 times the quantity negative x cubed. Okay? As a result, I get 4 times negative x times negative x times negative x. Okay, if I have 3 numbers that I'm multiplying together and all 3 of them are negative, these two are going to become positive. If you multiply by another negative, then you get a negative. So watch what happens. Okay, I'm going to get 4 times negative 1 times x cubed. Okay, and I pulled that, I just have that negative out there. I have that negative 1. So if I take, negative x times negative x, that's positive x. That's a positive x squared. Negative x, and that's the other thing, is like when I look at just negative x is equal to, it's the same thing as me saying negative 1 times x. I can kind of pull that negative 1 out. Kind of a tricky thing, but that's how I'm getting that down here, all right? As a result, look what happens. I have this entire function, 4x cubed, the same thing that I had up here, however, the entire thing is negative. Okay? And that's the same thing, and we have to think, okay, well, you have this, and you have this, all right? This is your original function. After you plugged in negative x, it made the entire function negative. That's what this means up here. Okay? If you have that function, you plug in negative x, then you make the entire function negative. That's what that notation means, negative f of x. All right? Okay, that's the idea. All right, so typically what you have is you have a graph that looks like this, if you have an odd function. All right, and what that means is that, okay, if I plugged in in the other one, and I'm just drawing here, but when you had, so you don't need to draw that, but if you had an even function, it was symmetric about the y-axis. Okay, where if I plugged in, say, positive 2, I got some y value. Okay, if I plugged in negative 2, I got that same y value. All right, the difference with an odd function is that if I plug in 2, I get some y value up here. If I plug in negative 2, I get the opposite y value. I get a negative y value. That's the idea.
But it'll be the negative or the same of that?
Right. Yeah, exactly. So we call that symmetric to the origin. Have you ever heard that term? Where it's kind of like, yeah, it's just opposite y values.
And if it's x cubed, does that mean that it touches the x-axis 3 times?
It can, but in monomial, no. It's just gonna touch it once. Yeah, when you have x cubed, then you have technically 3 solutions.
Oh, but then it would need to do like an x squared after that.
Yeah. We'll get into that next unit when you start having curves that do all sorts of stuff. Yeah, that's when the fun happens. Okay.
ask what the linear line is going through the past one?
Say that again.
The actual just linear line.
That's an odd function. Yeah. Y equals x.
Oh, okay.
Yeah.
Okay.
Yeah. It's an odd function. Good question. Okay, let's get our computers out. And I want you guys to do this next problem on your own. Okay, I want you to graph these monomial functions. You know, y equals x cubed, y equals x to the fifth, y equals x to the seventh, and so on. And then trace along the functions to check see what's true about all those functions. Okay. All right. So in this problem, we graph these three functions here, and we want to answer these questions. So does the graph open up? And the answer is no. Okay. A parabola was something that just opened up or opened down. This one actually does both. It actually opens down, and then it switches and it opens up. We'll kind of talk about that at some other point, but not right now. So that's not true, okay? Does the graph pass through 0, 0? And the answer is yes, okay? All those graphs intersect at that same point, okay? Is the graph symmetric about the origin? And that is true. That's kind of the definition of an odd function, is that it's symmetric to the origin. The graph only has one x-intercept. That is true. It only hits the x-axis at 0. It looks like it almost kind of like touches the whole axis, but it doesn't, okay? It just hits at 0. And then the same thing here. The graph only has one y-intercept, and that's true. It actually just hits at the origin, okay? So all of the last four of those are true, okay? All right, let's kind of take a look at this. And same thing with the other one. It is symmetric about the origin, okay? They all pass through the point -1, -1, 0, 0, and 1, 1, okay? And as the exponent gets bigger, okay, the line it's flatter here and then it shoots up, okay? Flatter here and shoots down. And then, if your exponent isn't as big, then it's more of a gradual value and it's not as narrow. Okay? All right, on this last one it says, let's kind of just take a look. And so it says for odd power functions where your leading coefficient is positive, as x gets bigger, okay, and let me just do this over here. Let me write down what this means. Okay, this would be something like y equals x cubed, okay? Actually, let's just call it like x to the fifth, okay? This graph here would be like y equals negative x to the fifth, okay? And so here's what you've got. You have as x, so if we talk about the odd power functions where a is greater than 0, so that would be the function y equals x to the fifth. Okay, as x gets bigger, what happens to the y values? The y values increase. Okay, the f of x increases. Okay, as x is negative, or as x gets smaller, what happens to the y values? The y values actually decrease. Okay, so it's kind of the opposite of what we had. On the other one where, let's say you have the equation y equals negative x to the fifth, okay, where your leading coefficient is negative, that's where that negative comes from. Then as x increases, what we notice is that the y values decrease. So the f of x decreases. Okay? And then as x gets more negative, the y values actually increase. So we increase here. Okay? And so that's what's going on. All right, on the next one, it kind of gives us a few examples, and what it says here is that if your leading coefficient is positive, then your function is always increasing. It's always going up this way, like that. Okay, if your leading coefficient is negative, like I have here, then the graph is always decreasing. It's always going down. Okay, if the leading coefficient is big, then the graph narrows. Okay, it gets really narrow. If the leading coefficient is small, then the graph gets wide. All right. So the one thing I do want you to do is find a spot where we can talk about end behavior. Because I want to put it in terms that make it easy. Because sometimes you have all these different variables. You have the a, you have the n's, and it's just a pain in the butt. And you know what? Let's make it easy. Okay. So let's write this down. This part down. So I'm going to write just end behavior. Okay, and we'll call this Police's version. Police's version. God, come on. So here's what I've got. You have 4 different options. Okay. You have where the exponent is even. So exponent is even. And the leading coefficient is positive. So lead coefficient is positive. Okay. And then you have the exponent is even and the leading coefficient is negative. Okay. So the most simplest example I can give you here is just the y equals just x squared, positive x squared. Okay. Your graph is going to look like this. Where it goes like that. Okay? So your end behavior is up to the left and then up to the right. Okay? So if this number here is positive and your exponent is even, it's always going to do that. Okay? On the contrary, if your exponent is even and your leading coefficient is negative, then that would be like the equation y is equal to negative x squared. All that's going to do is have that graph open down. And your graph is going to look like this. Okay? This means you go down to the left, down to the right. Okay? Again, my leading coefficient is negative. My exponent is positive. Or is even, sorry. Okay? All right, now let's look at another option. Either the other option is going to be that your exponent is odd and your leading coefficient is positive. The other option is that your exponent is odd and your leading coefficient is negative. Okay, so your simplest example here is the equation y equals x cubed. I always go back to that. Okay, y equals x cubed, that's your John Travolta, the Disco Inferno, when he does this. You guys ever see that movie, Saturday Night Fever? Awesome flick, okay? So, but I just remember that's just the John Travolta, okay? John Travolta is a major weirdo, but he helps me with cubic functions, okay? So you have this where you go down to the left and up to the right, okay? That's just your general function. So what that means, your end behavior means you go down to the left and up to the right, okay? Notice that your leading coefficient is positive and your exponent is odd. Okay, now the other one where your exponent is odd and your leading coefficient is negative, the simplest one you can have is y is equal to negative x cubed. All right? And all that's going to do is switch. So it's like the John Travolta going like this, and then the beat changes, and then he does this. Okay? So it's just gonna look a little bit different, but it's just going to switch. It's just going to be the opposite of what the other one was. Okay, so it's up to the left, and then down to the right. Okay? Yeah, Travolta's a major weirdo. If you do some research on him, Find some jacked up stuff. Jacked up like my teeth before I had braces.